Okay, so we were on question number 35, which said you were dropping a book from a height of 1.75 meters. The book's mass was 1.5 kilograms, and it wants to know the impulse that the floor is going to put on the book. Okay, so before we can figure that out, so the book is falling, right? And so we need to figure out what's the speed that the book hits the floor with. So this height is really a delta D. You're dropping it, so VI is 0. And A is 9.81 meters per second squared. And so from this we can find the speed with which the book hits the floor, using VF squared is equal to VI squared plus 2A delta D. So VI is 0, so VF squared is equal to 2 times 9.81 meters per second squared times 1.75 meters. Remember, this is VF squared. You got to take the square root and get a speed of 5.86 meters per second. So this speed is the speed with which the book hits the floor. And after it hits the floor, it's going to come to a stop. So this VF that it hits the floor with becomes the VI that it hits the floor with when we're looking at what the floor is doing to it. And the floor is going to bring it to a stop. So remember when we were doing the kinematic stuff, you all wanted to say that the VF was 0 when I dropped something or someone off the roof. No, the VF won't ever be 0 when you're dropping something. It'll only go to 0 after it hits. So in this case, we're looking at the hitting part, and we're saying what must the impulse that the floor has to put on the book to bring it to 0 if it was going this speed as it hits the floor. So we want J again, which is equal to M delta V. And so the M was 1.5 kilograms. And the delta V, which of course is VF minus VI. The VF, because it comes to rest after it hits the floor, is 0, minus 5.8 meters per second. And J will be equal to 8.79 kilogram meters per second. But it's a negative. And it's a negative because the floor is acting in the opposite direction that the book was moving in. We didn't put any negatives in here, which means we call down positive. So this negative means up. Now my money would be on that most of you did 5.86 minus 0. But that's not right, because it's always final minus initial, and after the book hits the floor, it stops. And so the final is 0, and just before it hits the floor, it's 5.86. Okay, so the impulse, the negative, yeah, it should be up because the book's going down. If you want to stop it, it needs to have an impulse in the opposite direction. All right, so then I asked you to do 5 from this sheet. So if you would find those ones. Number 1, a freight train having 85 cars and a mass of 8 times 10 to the 4th is moving down a track at 0.5 meters per second. So our total mass then will be 85 times 8 times 10 to the 4th kilograms. And it says the speed is 0.5 meters per second. And part A wants to know what's the momentum. So it's just looking for P, and P is equal to mv. So the M was 85 times 8 times 10 to the 4th kilograms, and the V, 0.5 meters per second. Okay, and when you do this, you get 3.4 times 10 to the 6th. 3.4 times 10 to the 6th kilogram meters per second. Part B says, what impulse would you have to put on the train in order to stop it? Impulse is equal to change in momentum. It's equal to M delta V. The M is still going to be your 85 times 8 times 10 to the 4th kilograms. Your delta V, which of course is V final minus V initial. To stop it, final is 0. Initial is 0.5. And so your J is going to be negative 3.4 times 10 to the 6th kilogram meters per second, where the negative means opposite motion. If it had told us the direction of the train, if it had said it was moving north or east or whatever, then this would be west or south or whatever. But it didn't tell us, so all we can say here is opposite motion. But whenever it tells us the direction, then here we would say the opposite direction, whatever that might be. So that's number 1. Number 2 says, how long? So we're looking for delta T. Must an unbalanced force of 500 newtons, so F is 500 newtons, act on a 1,500 kilogram car, 1,500 kilogram car, in order to increase its speed from VI, 5 meters per second, to 15 meters per second, VF. Okay, so we have an F, we have an M, a VF, a VI, we want a delta T, so we'll use F delta T is equal to M delta V. And we're solving for delta T, so divide both sides by F. And again, delta V is really VF minus VI. And so fill your numbers in. 1,500 kilograms, 15 meters per second, minus 5 meters per second, and then that's going to get divided by 500 newtons. Delta T equals 310, 30? I think it's 30 seconds. Gotta like it when the numbers are easy. Number 3. A ball that weighs, I'm giving you an FG, weighs 2.3 newtons, is moving with a velocity of 15 meters per second. So VI, 15 meters per second. When it's hit by a bat, causing it to move in the opposite direction, 30 meters per second. But they're opposite directions. So towards again, and away. Find the force if the by the bat if the blow lasts for so delta T lasts for 0.01 of a second. So up here, our first step, find M. So Fg is equal to Mg, so M is equal to Fg divided by G. So 2.3 divided by 9.81, and you get 0.23445, etc. kilograms. And it says find the force. Yeah, so you're looking for F. So same equation as we did above. F delta T is equal to M delta V, only this time you're solving for F. So M VF minus VI over delta T. So our 0.23445 kilograms. And again, towards and away. So if we call towards positive and away negative, then it'll be negative 30 minus 15 divided by 0.01. And when you do that, so what's that, negative 45 in the brackets, divided by 0.01, you should get 1,055.05 newtons. And it works out to be negative, which means for us away. If you called your other direction, if you called your directions opposite, it would work out to be positive. It would still mean away. Number 4, a car of mass 1,400 kilograms, so M, 1,400 kilograms, crashes into a solid wall and is stopped, delta T, in 0.05 of a second. The car was initially traveling 5 meters per second when it hit the wall. The VF is 0. What is the force that the wall must put on the car? So F delta T, M delta V. So F equals M VF minus VI over delta T. So 1,400. It stops, so this goes to 0. Negative 5 meters per second. And we're dividing by 0.05 of a second. And you get an F to be negative 1.4 times 10 to the, move it twice, 345, I think. I'm trying to do